Join the DZone community and get the full member experience. Join for free. This article looks at a benchmark passing events over TCP/IP at 4 billion events per minute using the net.openhft.chronicle.wire.channel package in Chronicle.wire, open source, and why we aim to avoid object allocations. One of the key optimizations is creating almost no garbage. Allocation is supposed to be a very cheap operation, and garbage collection of very short-lived objects is also very cheap. Does not allocating really make such a difference? What difference does one small object per event, 44 bytes, make to the performance in a throughput test where GC pauses are amortized? While allocation is as efficient as possible, it cannot avoid the memory pressure on the L1/L2 caches of your CPUs, and, when many cores are busy, they are contending for memory in the shared L3 cache. This doesn't sound like much, however, in this highly optimized, high-throughput context, this reduces performance by 25%. If this data has to be persisted, it must first be copied, because objects are reused to reduce object creation. Only 0.3% of the time was in the garbage collector. The total time spent in GC was about 170 milliseconds per minute, or 0.3% of the time. It is the allocations rather than the time to clean up these very short-lived objects that takes time. Allocation rate and average latency, a benchmark that just creates short-lived top-of-book objects across multiple CPUs, produces a similar result. This suggests that the rate new objects can be allocated is quickly saturated by even a small number of cores, increasing the average latency with more threads. This is for the same small 44-byte object. On a Ryzen 5950X with Ubuntu 21.10, Java 17.04.1. The benchmarks in this benchmark. 16 clients connect to a simple microservice that takes each event and sends it back again. All events are serialized POJOs with an event type. This translates to an asynchronous RPC call. The benchmark can be run in two modes, one where no objects are allocated and one where any object is allocated and initialized, allowing us to measure the difference this makes. Each event is modeled as an asynchronous RPC call to make testing, development, and maintenance easier. In other words, often to create low-latency software, developers adopt low-level techniques that are hard to read and maintain. This overhead can slow down your development. The code is available here. This library is used in Chronicle services. Conclusion: Java can be very fast, however, it can be well worth avoiding object creation. The cost of object creation can be far higher than the cost of cleaning them up if they are very short-lived. Java, programming language, object, computer science. Thanks for watching. Please subscribe.